Okay, so hello everyone. This is my second presentation about cryptocurrency trading. A month ago I covered the Elixir part, which was the API that communicated with Exchange. Today I'll talk a little bit about how I applied the machine learning to improve the accuracy of my classifier that trades cryptocurrencies. So firstly, I would like to say that at the time of making this experiment, I knew nothing about machine learning skill. I knew nothing about trading cryptocurrencies, and I only have about 15 minutes to tell you all this. So yeah, hopefully it will work out somehow. And first, I would like to start with a very simple thing, very simple example of classification problem. Let's say that we want to train a classifier that recognizes geometric figures based on amount of sides. So for example, we want to recognize triangles, quadrilaterals, and pentagons. This is fairly simple. I don't think it can get any easier than that. So on the left side, we have so-called features. And on the right side, the corresponding names of figures that we want to be recognized, those are called classes. And we can also extract more features if we want to, if the problem gets more complex and we want to be able to recognize more complex patterns. So well, in this case, all that we have on the left side of this table is called feature vector. This is a single data set that we can simply put into array. And on the right side, we need to prefill the data set with whatever we want to be recognized. So this is the code in Python. This is my hello world of machine learning, and this is all it takes to train this classifier. Firstly, we have two data sets. Well, only one data set. X is the array of feature vectors. In our case, it's only sides. And Y is array of the classes that are corresponding. So this is our training data set. The next two lines, we instantiate the classifier, and we simply fit our data. And then we can test. We have another data set. Usually, you don't want to test the data set on the same thing as you trained it. And in our case, as we can see below, this is 100% correct, and we also get correct. We can recognize the geometric figures correctly. So this is a very simple example. This is basically the first thing I made in machine learning. And unfortunately, in my case, the trading problem that I wanted to solve is a little bit more complex. I wanted to create a classifier that could give me some trading signals based on following rules. When there was some price change, at first it would only take price from 5 minutes ago and current price. And if there was a significant increase, it was a buy signal for it. And likewise, when the price decreased a lot, by a lot I mean more than a transaction fee would cost, it was a sell signal for my bot. Otherwise, it would recommend to hold the money and do nothing. So what I did, I gathered some historical data, actually a lot of historical data. It was a few years of data for about 70 different Bitcoin and altcoin markets. And in the beginning, I only used the closing price. As you can see, there is a lot more, but it will come in handy later. And so the simulation was, I prepared some simulation to verify whether the results were okay. So I trained this classifier using data from one single market. Then I prepared simulations on remaining markets, and I went manually through those results. I also assumed that the fee was always the highest possible on that exchange. And I also gave the bot, during the simulation, I assumed that it has $10 worth of Bitcoin to trade with. So those are some selected results of the first simulations. For example, let me explain what's going on here. So there are two charts. The upper chart is the price market over time. This is Digibyte cryptocurrency. And there is, as you can see, there is a lot of black lines on this chart. I used it so that I could see when my bot decided to make a buy or sell call. Whenever a line appears above the chart, it's a buy signal, and whenever it's below the chart, it's a sell signal. And on the bottom chart, this is the simulated portfolio over time that the bot owned. So in this case, the problem was that the bot would simply make too many unprofitable trades, and as you can see, it basically ended up losing the whole money that it started with. Another example is this one. It would make a lot, it would actually make very few trades over many years, because this is data from like 2 years, from over 2 years, and it would not, despite increasing the portfolio by a bit, it's still not enough to, it's not significant enough over 2 years. So those were usually the two most common problems that I struggled with initially. So I did some things to improve the model. First, I extracted more features from my data set, so-called technical analysis indicators. I tried different classifiers, algorithms, and parameters. Basically, it was I didn't know really what I was doing, so I was sort of following my gut, and I was brute forcing through different possible combinations, and then comparing results. If they were getting better, then yeah, it was okay. So let's talk a little bit, explain quickly what's technical analysis. So in finance, technical analysis is an analysis methodology for forecasting the direction of prices through the study of past market data, primarily price and volume. This is the definition from Wikipedia. Basically, some people would say that it's a complete bullshit. They don't think that technical analysis works. But there is also some people will tell you that it's very useful in predicting stock price movements. I personally think that the truth is somewhere in between, and I decided to give it a try for my classifier. And yeah, there are like hundreds of different technical analysis indicators that are available, and I was able to calculate most of them having the data, the historical data. But I picked those because I went through some research papers that covered the topic of automatic trades and applying machine learning to it. And this is the list that I computed, but I don't really understand what most of those do, so don't ask me. And I also tried different algorithms to tune up the accuracy of the classifier. Luckily, with scikit-learn library in Python, it's really easy to switch between one and another, because you just simply, it gives you so many tools that are ready to use. You simply import them and call fit on them. So finally, the best algorithm that ended up working the best for me was AdaBoost. This is the definition. AdaBoost is exactly like human specialization. Get person, weak learner, A, to learn problem X. Whatever part of X A is not good at, get person B to learn that subset. Whatever A and B are not good at, get C to learn that, and so on. Each learner specializes in the weakest area that needs the most improvement. This is a nice definition that helped me understand what's going on, at least on the surface. And what happened with my simulations after I improved, after I've done all those improvements. So this is like, I decided to pick this example. So, but despite not making a lot of trades, it gained a lot of Bitcoins over a few years. So it starts with like $10 and it exits with hundreds Bitcoins, which is like, I'm okay with this. And another example is, this is my favorite. It seems to do nothing because I think that's because of the incorrect scale on the bottom chart. But suddenly, as you can see, it's like you can see the number up there. So that's not even possible in the real market. So, but I liked it because I had like a lot of charts like this, and at this point I was very hyped to test it in production. And also one more example is this one. There are not many traits, but I like how this one shows that the classifier manages to capture when the market trend is turning. Then when it's trending upwards, it's trading a lot. But as soon as the trend turns, it's suddenly trading a lot less. So I personally liked this one, despite only returning 1 Bitcoin. And like I said before, at this time I was very hyped to try it out in production, and because I knew that somewhere I had to make some mistake in my assumptions and calculations. So that's when I quickly developed the Elixir API that I talked about on my previous presentation, and then how it went in production. So yeah, simulation is not reality. It turned out that I made quite a lot of bad assumptions. So the bot was trading, but it was slowly losing money over time, which was expected, to be honest. Then I made a few tweaks that fixed some initial problems. It still kept losing money, but I noticed that sometimes it can make small profits, but it was still not enough to. It was still not enough for me to know whether it was lucky or whether it was working okay, because I only tested it for I only managed to test it for about 2 weeks, because then the exchange that I was using suddenly experienced a huge increase of user base, and it was lagging a lot. It was often going down, and then they reacted by making more stricter API rate limits, so which basically made my API bot useless, and I would have to rewrite it to continue my tests or move to a different exchange, which I had no time for. So the pre-alpha version certainly does not look good, but to be honest, I expected it to lose the money a lot quicker. So to summarize, the time frame for this project was about 6 weeks. I lost about $10 so far, which is about 3 grander Texas burgers. And so the good parts are that I learned a lot about machine learning. That was my first successful project when it comes to machine learning. And I also managed to not only get into the machine learning, I also managed to improve the initial simulation, which actually they are still not perfect. But I think it was very nice, given how little time I spent on this. And that was one of the most exciting projects that I have been working on since ever. And it's still not done, although it's a bit stalled recently. I still see a lot of ideas how I could improve accuracy of the bot. I could tweak the API in Elixir, apply different trading strategies, or move into different exchange, since the old one is unusable currently. Yeah, so basically, I would also like to recommend the scikit-learn library to anyone who would like to try machine learning in Python. It has a lot of tools that you would otherwise have to prepare yourself. It can pre-process your data. It has lots of classifiers and other models, and it has even ready data sets that you can import and learn. Those are very popular data sets that are widely used by people who are trying to improve their skill in machine learning. And it's all available in this one library. So I would highly recommend trying this out if anyone wants to get in. Yes?
Did you compare it with TensorFlow or something?
To be honest, I haven't tried TensorFlow, but TensorFlow is more focused on making neural networks, as far as I know. Correct me if I'm wrong. And the upside of TensorFlow is that it can utilize your GPU. This library won't. So the computations will be significantly slower, but it depends on your problem, to be honest. I don't want to assume anything here, but I think 90% of, if you just want to try something out, I would recommend this one. It's really simple, as you saw in the example that I showed in the beginning. It's just a few lines of code, and you already get some results out of it. Any more questions? Yes?
There are some nice visualization tools for this library. Did you use it?
I used, for the charts that you saw earlier, I used, I think it was Matplotlib or something like that.
Because I saw that the tools often in machine learning, you often like
Yes.
analyze the results by the plots.
Yeah.
How it hits, how it matches or not.
I'm not sure if it has any built-in tools for visualizing the data, but if the library itself does not, then you have a lot of options. It's Python. There are so many tools that you will surely find something. Okay. Any questions? Okay.
Do you plan to continue your experiment?
Yes, someday I plan to when I get more time, because like I said before, there are a lot of possibilities for improvements there. It's definitely not finished, and I was it was kind of unfortunate that the Exchange blocked API requests, and I was unable to continue mostly because of this. Okay, so I think that's all. Thank you.